The variation of sampled data is really just the same as the variation of population data. The difference is in the symbols and one little thing. So I'm going to draw a line here. So this is variation of population data, or actually variance, sorry, which we called sigma squared. And here's the formula we had in the last video I did. Here is the variation for standard deviation, which we talked about was distance. And we use sigma to represent that, which is just the square root of the variation. And notice the difference between the two. Now this side's population. If you have all of the data, you're going to use this formula. If you only have part of the data, or a sampled piece of the data, this is the sample variance, and this is the sample standard deviation. Okay, the difference is in the terms. X bar means sample mean. Mu was the mean of the entire population. They're figured the same way, only you figure it over how many you have in a sample versus how many you have in the population. But they're basically, it's mean and how you're used to calculating it. S squared then is variance, and S is your sample standard deviation. So we represent it with the letter S. Notice the difference. The only difference, everything else is the same, except for now instead of dividing by the population size, you're going to divide by N stands for your sample size, but you're going to subtract 1 from it, which will make a larger variance or larger standard deviation, because typically you're not working with the whole population, so you got to do it, work with a part of the population. And so your sample sizes are much smaller. And so you basically make your variance larger to incorporate the fact that you don't have all the data. And so let me just show you what this is. It's not as hard as those formulas, again, make it look kind of nasty, but it's really not that bad. If you've done distance formula, you can do this. So you're studying the size of you're studying the size of litters female Yorkshire Terriers and Black Labs produce. You select 6 female Yorkshire Terriers at random from kennels in the state of Nebraska and find that these females had litters of size 1, 2, 2, 2, 2, and 3. You select 5 female Black Labs at random from kennels in the state of Nebraska and find that these females had litters of size 3, 5, 9, 12, and 16. So here's the deal. You don't usually find variance just to find variance. I mean, there's times when you do that, or standard deviation. There's times when you do that. But in our case, we're going to probably use it for a study, like maybe some hypothesis testing or something like that. But anyway, we're going to need to find it. And so, so what we do then is we'll go ahead and find the sample standard deviation and sample variance with the 2, 2. So it was 1, 2, 2, 2, 2, and a 3. And so to find that, first off we find our mean, which is the same as we've always done. You add them together, divided by, there's 6 of them. And so you add all those up, divide by 6, you get 12 over 6, which is 2. So there's your sample mean. And then your sample variance, S squared, would be kind of like what we did variance. So it's going to be 1 minus 2 squared plus 2 minus 2 squared plus 2 minus 2 squared plus 2 minus 2 squared plus, there's 4 of them, 1, 2, 3, 2 minus 2 squared plus 3 minus 2 squared, all over. And here's where the difference lies. Instead of 6, it would be 6 minus 1. So then you keep going, go ahead and simplify it, and you'd have negative 1 squared plus 1 squared, because the 2 minus 2's are 0, and that would be 5. And then that simplifies to 1 plus 1, which is 2, over 5, which is 0.4, or 0.4. So there's your variance. To find standard deviation, you just take the square root of that. So S, which is standard deviation, is the square root of 0.4. which is approximately equal to, I suppose I should have squigglies, 0.632. And so my sample standard deviation is 0.6 if you go to one more decimal place. And so there's your variation for the Yorkshire Terriers. Very small. 0.6 is very tiny variation, which hopefully makes sense. Okay, the Black Lab puppies, there we have, those puppies were, the first litter had 3, then 5, then 9, then 12, then 16. Okay, to find your sample standard deviation with this, first off again you need X bar, which is 3 plus 5 plus 9 plus 12 plus 16, all divided by the number of samples that we have, which is 5. And that'd be 45 over 5, which is 9. So your mean of our sample is 9 puppies. Okay, then to calculate sample standard or variance of that, you would take 3 minus 9 squared plus 5 minus 9 squared plus 9 minus 9 squared plus 12 minus 9 squared plus 16 minus 9 squared. And again, you divide it by the number of samples minus 1 to get a larger, slightly larger standard deviation. Okay? And so now it's just a matter of simplifying this using your order of operations. So your variance equals 3 minus 9 is negative 6 squared plus negative 4 squared. Excuse me, let me put those in parentheses. Plus 0 squared plus 3 squared plus 7 squared, all over 4. And so s squared is equal to, and if you simplify all that, you would have 36 plus 16 plus 9 plus 49 all over 4. And I do believe that's 110. I didn't write it down. So 36 plus 16 plus 9 plus 49. Yep, that's 110 divided by 4. So my variance, if you divide that by 4, is 27.5. So much larger than the 0.6 we got, or 0.4 we got with the Yorkshire puppies. And then, so the standard deviation, which is actually the average, again, we're finding the distance, the average distance of all of your points from the mean. So in this case, you take the square root of 27.5, and the square root of 27.5 is approximately equal to 5.244. And so, you round that to one decimal place beyond the data we have, which would be 5.2. So there's your standard deviation, which again, there's much, we have a much larger spread of data with these black lab puppies. And so there is your sample standard deviation and sample variance and how to calculate that. So good luck. I hope this helps, and see you next time.